on Wednesday, we talked about adding and subtracting our polynomials, right? And when we added or subtracted our polynomials, we just put our like terms together. We didn't change any exponents or anything, okay? But today, we're going to be talking about multiplying different polynomials. And when you're multiplying monomials together, guys, remember, when you're doing this, guys, when you multiply monomials, the first thing you always want to do is you want to multiply your coefficients, right? You want to multiply those coefficients. And then, if the bases are the same with your variables, if the bases or variables are the same, what do you do to those exponents? You add your exponents. All right, guys? So, if you multiply your coefficients, and then if the bases or the variables are the same, you add your exponents. All right? So, just a quick refresher, these are actually very similar to the ones that we did in our last unit. We're going to do a couple examples right here. 6x cubed, and oops, that's supposed to be a negative 4x to the fourth. Sorry about that. Then I'm going to write down my second example here. 5xy squared and 7xy. So I'm going to give you guys a second to write that down. And guys, while we're doing this, remember, when you multiply your monomials together, you multiply your coefficients, and then if your bases are the same, you add your exponents, right? And so, I'm going to take a look at this, and we're going to sit here and we're going to say, cool, well, I'm going to start with my purple, all right? So we have 6 times negative 4, so that's going to give me a negative 24. Are you guys comfortable with that? And then we have x cubed times x to the fourth, so that's going to be x to the 7th. Is this ringing any bells on how we did on this last test, right? So we have negative 24 x to the 7th, right? Okay, for our second example here, we want to again multiply our coefficients. So we're going to do 5 times 7, so that's going to give me 35. And then we're going to go, we have our x, and that's really like x to the 1 times x to the 1. So guys, what is x times x? X squared. All right? And then we'll go here. We will have y squared times y to the 1, and that would give us y cubed. All right? So you multiply those coefficients, and then you add the exponents together. Do y'all feel pretty good about this? Is this a good refresher on what we did before Christmas? I hope so. All right? It's going to get a little bit more exciting here. All right? So here we go. I'm going to look, we're going to do number 3 now. And I'm going to write this as 3x, parentheses, 3x squared plus 6x minus 5. So now we have a monomial times a trinomial. All right? And so what's important to notice, guys, if there are multiple terms in the parentheses, you need to distribute. All right? So if there's multiple terms in the parentheses, we need to distribute. So this is how this is going to look here. All right? So I'm going to use all my different colors. It's okay if you don't use different colors. But for now, I do want you guys to do the arrows. I know that's annoying, or I know it can be, but it will help us make sure we don't make any mistakes here. So if we do 3x times 3x squared, that would give me 9x cubed. Y'all feel good about that? And then if we do 3x times 6x, well, 3 times 6 is going to be 18. X times x is going to be x squared. And last but certainly not least, 3x times negative 5 would give me 3 times negative 5 is negative 15, and then we just still have our x. So our final answer would be 9x cubed plus 18x squared minus 15x. Y'all feel good? Okay? So, and here's the deal. We look at this and we say, none of these terms are like terms, so we can't combine them. So when we do this, we're just done. We're done now, which is awesome. Okay? So now I'm going to take a look at our next one here. And let's go ahead. This is going to be 5x squared plus 3xy squared plus 7xy times 2xy. So now, it might look a little bit funny, but my monomial is here at the end. My trinomial is in the front. You're still going to do the same thing, y'all, but we're just going to do it from the right side instead of doing it from the left side. Are you guys comfortable with that? So we're just going to do it from the right side instead of the left side. So I'm going to go here, and I'm going to go all the way to xy times 5x squared. So 5 times 2 would be 10. X squared times x would be x cubed, and then I still have my y. So we have to make sure we are looking at each variable. All right? And then I take my 2xy, and I'm going to multiply it by 3xy squared. So 3 times 2 is 6. X times x is x squared, and y squared times y is y cubed. And last but certainly not least, we have 2xy times 7xy. So 7 times 2 is 14. X times x is x squared, and y times y is also y squared. Now before I finalize my answer here, I'm going to take a look at these and I'm going to say, do any of my variables, do any of my terms match exactly the variables and coefficients? No. So because none of them can be combined, this right here is our final answer. Do y'all feel good about that? Okay. So now we're going to do another one here. And I want you guys to actually do this one on your own. We have 5b squared minus 3ab plus 6a minus 1. And that's going to be times 2a squared. So guys, I want you guys to go ahead and copy that one on your own, on your paper, and then we will go over it together in just a moment. All right, so we're going to go ahead and pick up here. So 2a squared times, 5b squared. So Maria, I want you to start us off because I know you got this one. Can you tell me what our first term will be? Yep. B squared. Perfect. 10a squared b squared. And guys, I liked the way that Maria was going through this because you can tell she was doing each term one at a time. You think, okay, first I'm going to do my coefficients. 5 times 2 is 10. Then I look at my a here. That's the only a, so it's just a squared. Then I look at my b variable. That's the only b, so it's just b squared. So I did my a, my coefficients, then my a's, then my b's. We're going to do that every single time. We're going to follow that pattern. All right? So Rachel, you want to help me out with the second term? Excellent. You're okay. We're going to do A3, A cubed, so it's negative 6A cubed, and then we still have just the B. Perfect. So you can do it kind of one step at a time. So negative 3 times 2, then my A times my A squared, and then my B. All right? And then we're going to go here with our next term. All right, Andrea, you want to help me out? I'll go with Andrea, and then Andrea, the other Andrea gets the next one. Okay? All right. So Andrea R. Yes, ma'am. We're going to say plus 12A cubed. All right? And then Andrea L, will you bring it home for us? Perfect. Minus 2A squared. All right, guys. I know I'm being a little bit tedious about this, but it's just because I want to make sure that we get this right, that we do it well. Do you guys feel good about this so far? Okay? So really, all we're doing is we are taking our little guys and we're distributing. Okay? So I'm going to give you guys another little example here. Okay? And I want you guys to simplify this following expression. All right? So number 6 here, it's going to be 2x times 4x minus 5 plus 3 times 6x plus 7. Okay, guys? So we're going to do a couple more. I'm going to do this one with you guys, and I'm going to give you guys 2 more to do on your own. All right? So let's check this out. The very first thing we're going to do is now we need to distribute both of these and then combine them. So 2x times 4x is going to give us 8x squared, because x times x is 8x squared. And then 2x times negative 5 gives us negative 10x. And then we're going to move on to the next set here. 3 times 6x is plus 18x. And last, but certainly not least, 3 times 7 is plus 21. Do you guys feel good about that? So that is what we have done here. So those are all, we got all these lovely positives. But we are not simplified completely. Because look here, the 8x squared is good. So that one, there's no other terms that go with it. But we have a negative 10x and a positive 18x. And negative 10 plus 18 is going to give us plus 8x. Do you guys feel good about that? And then last but not least, we have plus 21. So my final answer would be 8x squared plus 8x plus 21. All right? And guys, the important thing to notice here is when you multiply monomials, you do change your exponents. But when we add or subtract, do we change the exponents? No. All right, guys? So this is one of the places that people make the most common mistake on, is they'll sit here and they'll say, oh, I've changed my exponents when I multiplied, and then they change it again when they start to add because they just get in a rhythm. So guys, remember, when you're multiplying or dividing, that's when you change your exponents. But if you add or subtract, you don't change your exponents. All right? Y'all feel good about that? Pretty good? Awesome. Can I move on, or does anyone else still need this up here? All right. So here we go. We're going to do these next 2 pages, next 2 examples here. All right? So I want you guys to simplify these following problems all on your own. So we have 3/5 times 5x plus 15 minus 3x, parentheses, 3x minus 6. All right. And then I'll give you all a little bit of space here. And I'm going to go with 2x times 4x minus 7. Ooh, this is a long one. Plus 4 times 2x minus 6 plus 7 minus parentheses 3x minus 5. All right, guys? So I'd like y'all to do these two problems on your own, and then when we're done, we will go over them together as that. All right, y'all. So if you take a look at, if you guys want to take a look at these guys right here, let's take a look at number 7 and 8. So for number 7, guys, our final answer was going to be 15, correct? Because 3/5 times 5x gave me 3x. 3/5 times 15 gave me 9. Negative times 3x gave me negative 3x. And negative times negative 6 gave me that positive 6. Remember, we got to switch both those signs. 3x minus 3x, that just cancels out to be 0. And 9 plus 6 gave us 15. All right? If you look at example 8 here, you can see that 2x times 4x gave us 8x squared. 2x times negative 7 gave us negative 14x. 4 times 2x gave us positive 8x. 4 times negative 6 gave us negative 24. Then we just had our plus 7 in there. Then negative times 3x gave us negative 3x. And negative times negative 5 gave us plus 5. So then, my 8x squared stayed my 8x squared. Negative 14x plus 8x gave us what? Negative 6x. Minus 3x gave me that negative 9x. And then I combined all of my constants to get negative 24 plus 7 plus 5, and that gave me negative 12. Are you guys tracking on number 7 and 8? How do we feel about those guys right up there? So guys, honestly, the biggest thing is just multiplying your monomials by every term inside that parentheses, and then making sure. So you guys feel good about that so far? Awesome. Okay, so now we get to do a new concept, all right? So now we are going to talk about double distribution. Double distribute, all right? And this is when we do a binomial times a binomial, all right? So this lovely thing is called double distribution or double distribute, okay? When you do a binomial times a binomial, all right? So I'm going to take a look here. We're going to look at this, and I'm going to write this first one out as 2x minus 1 times 4x plus 5. So now I don't have a monomial, I have a binomial. So guys, this is super important. Sophia, let's start up on Y, okay? So guys, this is super important because this is a newer concept. You might actually be a little familiar with it because of biology, but we're going to do this here. All right? I know you're like, what? But if you guys have done Punnett squares and you guys have done like G, this is very similar. All right? So let's check this out. So guys, 2x times 4x, we're going to go here and we're going to, just like normal, I'm going to do 2x times 4x, and that is going to give me 8x squared. All right? And then I'll go to my next term here and say 2x times 5, and that's going to give me 10x. All right? But we did the first term. Now I need to do the second term. So now I'm going to go here. I'm going to say negative 1 times 4x. And that gives me negative 4x. And then again, I'm going to do negative 1 times 5. And that gives me negative 5. So now I have double distributed, all right? I distributed my first term to both of those guys, and I distributed my second term. Do you guys feel good about that? But once we've double distributed, guys, pretty much every time, most of the time when you double distribute, you are going to then have to simplify this because this is not fully simplified, right? We need to go here, and we are going to say, well, 8x squared, are there any other x squareds? Nope. So it's just 8x squared. But we do have 10x and negative 4x. Do y'all see that? So guys, what's 10x minus 4x? 6x. And last but certainly not least, my negative 5. So our final answer for this problem would be 8x squared plus 6x minus 5. Do y'all feel good about that? Okay, so we double distribute, and then we combine our like terms here. All right, so now I'm going to give you guys a second example. 3x squared minus 2x times x plus 5. All right, so I'm going to have you guys walk this through it for me, okay? So gentlemen, y'all, I would love for you guys to help me out with this. All right, so Will, help me out here. If I do, yes, all right.
X squared times x.
Okay, and what's that going to give me?
3x to the third.
Very good. All right, Michael, you want to back them up with the second term here. We have 3x squared times 5. So what's that going to give us? 15x squared, right? Because we still have that x squared right there. So it's 15x squared. Excellent. Gus, you want to go here with the third term?
Okay, so we go negative 2x times x.
Yep.
And then we get negative 2x squared.
Negative 2x squared. Oh, no. Yes, we got negative 2x squared here, don't we? And then last, but certainly not least, we're bringing it home. Weston, we'll just do all the boys over there, all right? So, Weston, what's this going to be for us?
Negative 10x.
Very good. We're going to do negative 2x times 5 to get negative 10x. Awesome. But we are not done, are we? Because, Finn, what do I need to do now? I need to simplify it. Are there any terms that can be combined here? 15x squared? Yeah, and negative 2x squared. Excellent. So what is my new middle term going to be, Finn?
Positive 13x squared.
Yes, positive 13x squared. Okay? And then we go here, and we still have negative 10x. So my final answer would be 3x cubed plus 13x squared minus 10x. Y'all feel good about that? So guys, double distribution is not too crazy, but you just got to make sure that you don't miss any little steps here along the way. All right? So then I'm going to look at something like this, 2x minus 5 squared. And then for number 12, I'm going to write over here x squared minus 4 times x squared minus 4. All right. So these guys are actually special. They're kind of special, so we're going to talk about it. First of all, this 2x minus 5 squared, we can't just do the square in here on each of those. We want to go ahead, and I want you guys to rewrite this as 2x minus 5 times 2x minus 5. Okay? So I want you guys to go ahead and rewrite it just like so. All right? So we're going to go ahead and pick on a different set of individuals here. All right, but because I didn't get to Adrian. Adrian, will you help me out with what is going to be my first new term here?
Multiply 2x and 2x.
Yep. And we get
4x squared.
4x squared. That's exactly right. So we get 4x squared. And then we're going to go here for our second term. And I've already picked on pretty much everyone in this front group pretty good. So Rachel, I know I've already picked on you, but I'm going to pick on you again. We're going to do 2x times negative 5. So what do I get? Yes, negative 10x. Amari, you want to help out with the next one here? What are we going to do? We distributed the 2x to both of them. So now we're going to go with our negative 5, right? Negative 5 times 2x is negative 10x. Negative 10x, okay? And then, Ian, you want to help me out here? Negative 5 times negative 5 is going to give us what? Yes, positive 25. And then, Eric, you want to help me out? How are we going to simplify this guy right here? Yeah, we're going to have to combine our negative 10x and our negative 10x. That's going to be negative 20x. We still have 4x squared plus 25, right? So it doesn't matter to me which order you do it in. You can write it out all at once, or you can think, oh, I'm going to combine those middle terms. But this right here is a great example of that middle term there. All right, guys? Do y'all feel good about that? Cool. All right, now we're going to take a look at number 12 here. All right, so Rika, you are up, my dear. All right, so what are we going to do? What's the first thing? Okay. So which one do you want to start with? Perfect. And what's that going to give us? Yes, ma'am. Okay. And then our next term here, Miss Sophia, what are we going to do? Ooh, so I would do x squared again. Here's the deal. If you did that, it wouldn't be wrong, okay? So hold on. I'm going to do this real quick. So you said -4. Would you go there to that x squared? So that would be -4x squared. Cool, right? You could do that one first. But then you would still have to go back and do the x squared times the -4x. But what's really interesting is they're actually the same this time, which is that's a little bit unusual. That doesn't happen often. This is a special case. All right? And then, Abby, what are we going to do for our last term here? -4 and -4. And that's going to be 16, right? So we have x to the 4th minus 4x squared minus 4x squared plus 16. And so, Stina, do you have any suggestions on what we need to do now? Yeah, we're going to put our -4x squared and our -4x squared together to get a -8x squared. Are you guys good with that? Oh! Oh, no. You know what this was supposed to be, guys? I did the problem wrong. This was supposed to be a plus. Dang it. That's okay. All right. You guys bear with me for just a second. So that was supposed to be a plus. And this changes it a little bit because it makes one of my 4x squareds positive and one of them negative. And it makes my 16 a negative as well. I'm sorry, guys. And then right here, so Stina, if that was the case, if we had -4x squared and positive 4x squared, what would actually happen? They would cancel out. You're absolutely right. And what we'd be left with is x to the 4th minus 16. Okay? Now, the reason why that was supposed to be the example is because I was going to show you guys these are two special cases. All right? This guy right here on the left is what we call a perfect square trinomial. This guy over here on the right is the difference of two squares. All right, guys, so check this out. I'm so sorry. So, guys, this is called a perfect square trinomial because this is a binomial that got squared, and it will follow the same pattern every single time. This is a binomial that is almost exactly the same, but one is negative and one is positive. Gentlemen, come on. So, guys, one is negative and one is positive. And so, guys, check this out. What's really neat to see is some people, when they saw this first problem, they would look at that and they would be like, oh, well, 2x times 2x would just be 4x squared. 5 times 5 is just 25. But it has this middle term in here. And, guys, the cool thing about a perfect square trinomial is it follows the same pattern every time. Because what you do is you square your first term and you square your last term. But how you get the middle term is, look, you do 2x times 5, or -5, to get -10. And you double it to get -20. And it's going to follow that pattern every time. This is going to be super important when we get into our next unit. So I wanted to make sure I introduced it to you guys. And this guy over here is a difference of two squares. And guys, when you look at the original factors up here, you have an x squared minus 4 and an x squared plus 4. They're almost exactly the same, except for the plus and the minus. Do y'all see that? So this right here would be a difference of 2 squares. This guy over here would be one of our perfect square trinomials. All right? And so those are some good little examples. You're going to have lots of time to practice that on your homework. All right? And then I'm going to get into our very last page of notes today. So what I would like you guys to do is I'm going to put a couple little problems up here. I want you guys to do these on your own. So we have number 13 is x squared plus 3 times x plus 6. And then for number 14, I'm going to go over here. And I'm just going to write 4x minus 3 squared. All right, guys? So this guy right here is going to be another perfect square trinomial. So I want you guys to do numbers 13 and 14. And then we will get, look at our very... All right. So here we go, 13 and 14. So when we're looking at these, what I want you guys to see, and I've already kind of written the next ones, but so 13 and 14. If you guys look at 13 here, we're also going to do triple distribution in just a second. But guys, 13 and 14. When we see x squared times x, that gives us x cubed. X squared times 6 gives us 6x squared. 3 times x is 3x, and 3 times 6 is 18. Now, guys, I did not need to combine these. And remember, when you guys, I didn't need to combine any like terms because none of my variables matched exactly. And so, guys, remember, standard, if it asks for standard form, is from the highest exponent to the lowest exponent. So on your homework, guys, it's going to ask for you to put it in standard form. And if you don't put it in standard form, it's going to be grumpy with you. Okay? So you have to make sure you do it from the highest exponent to the lowest exponent. So if you got these right things and you had x cubed plus 3x plus 6x squared plus 18 and you put that in, it would count it wrong. You have to make sure it's in standard form. All right? And then for number 14 here, we rewrote it as 4x minus 3 times 4x minus 3. And we got 16x squared minus 12x plus 9. My negative 12x and my negative 12x, they didn't cancel out. They combined to make us negative 24x. 6x squared minus 24x plus 9. This is a common mistake when people see this. They think, oh, and they just cancel it, and they get rid of it. But no, negative 12 minus negative 12x minus 12x is negative 24x. If it was negative 12x plus 12x, then it would cancel, okay? All right, so guys, up next, we are going to be talking about triple distribution. Okay, guys? So this happens when you have a binomial or a trinomial times a trinomial. So guys, sometimes you have to triple distribute. You have to distribute it to each thing inside of your parentheses. So if you guys want to get these examples down, this is all that we're doing today. If you guys want to make sure you get these down on your paper, we're going to go through them here together in a second. So in order to write them down, Will, you'll need to be holding a pencil. In order to write them down, you'll need to be holding a pencil. Yes, there we go. Cool. I wish I could write it with my mind, but I'm not there yet. Don't think we've progressed as human beings right there, okay? Maybe one day. All right, so here we are with our triple distribution. The biggest thing that we have to do is now we just do it 3 times instead of doing it 2 times. Does that make sense? So I take my 3x and I'm going to multiply it by my, I was going to do it with purple first. Look at me, I'm already screwing up. All right, 3x times x cubed is going to be 3x to the 4th. Are you guys comfortable with that? Okay? And then we're going to go to our next one here. 3x times x times 4x squared. And that would give me plus 12x cubed. And then last, but certainly not least, we're going to do 3x times negative 7. So that is just going to be negative 21x. Okay? So I did that 3 times. I triple distributed that 3 times. All right? Now we're going to start with our next ones. So then I do everything again, but with the 2. So positive 2 times x cubed is going to give me 2x cubed. And then positive 2 times 4x squared is going to give me 8x squared. And last, but certainly not least, positive 2 times negative 7 is going to give me negative 14. Okay? Now that we've written it all out, we can go ahead and combine our like terms. So I look at this and I say, cool, are there any other x to the fourths? Nope. So I'm going to write this in standard form. So I'm going to start with my highest exponent. So I'm going to write that as 3x to the fourth. And then I go to my next one here. X cubed. We have a 12x cubed and a 2x cubed. So that's going to be a 14x cubed. All right. Then I need to look for x squareds. So my x squareds would be here. So I'm going to do 3 little lines. That looks like that's my only x squared. So I'm going to say plus 8x squared. And then I look for just my x's, which are right here. So I'm going to do a little squiggle. And that's just negative 21x. That's my only x. And last, but certainly not least, is my lovely little negative 14. So I'm just going to say negative 14. So my final answer, after combining all my like terms, would be 3x to the fourth plus 14x cubed plus 8x squared minus 21x minus 14. Do y'all feel good about that? All right. Another way that you can do this is you can also go ahead and kind of stack like terms on top of each other. Come on, man. So we're going to stack like terms on top of each other. So I want to show you guys a little bit of a different method that you might like better, especially when you have triple distribution, okay? So for the number 16 here, I would do x times 2x squared, and that would give me 2x cubed. Y'all good with that? Then we're going to do x times negative 5x, and that gives me negative, not 10. Whoops, sorry, negative 5x squared. Okay? And then last, but certainly not least, I'm going to do x times 4, and that's going to give me plus 4x. Okay? Now, if you want to do kind of the stacking method, what you would do next is you would line up like variables with like variables. Okay? So right here, for my next term, I would say 2 times 2x squared. Well, that's going to give me 4x squared. So I'm going to put it right underneath my other x squared. Does that make sense? So I can kind of stack them. And then I'm going to go here, and I'm going to say 2 times negative 5x, and that's going to be negative 10x. So I'm going to stack it right underneath my other x. And then last, but certainly not least, we have 2 times 4. So that's going to give me plus 8. There's nothing to stack it under, so I'm just going to kind of put it off to the side. And now, so instead of writing it out all long, I've kind of stacked my like variables underneath my like variables. Does that make sense, y'all? So then we're going to go here, and I'm going to say 2x cubed. Well, there's nothing underneath it, so it's just 2x cubed. Negative 5x squared. Oh, did I do something wrong? Oh, plus 4x squared is just going to leave me with negative x squared. And then 4x minus 10x is going to give me negative 6x. And last, but certainly not least, we have positive 8. So my final answer for this problem would be 2x cubed minus x squared minus 6x plus 8. So guys, it doesn't matter to me if you write them all out horizontally and then combine them, or if you kind of stack them on top of each other and add them together. It doesn't matter. It's just two different methods to do the same thing. Do y'all feel good about that? Cool. So what I want you guys to do is I want y'all to do number 17, and then you can check your answer with me up here on the board, and then you guys can go ahead and get started on your homework. So let's go ahead and get started with that number 17, and then I'm going to write the answer up. All right, yes. So guys, this is our correct answer for number 17, and you see that when I did the stacked method, you also could have just gone straight across, but 2x times 3x squared was 6x cubed. 2x times 4x was 8x squared. 2x minus 7 gave us negative 14x. Negative 5 times 3x squared was negative 15x squared. Negative 5 times 4x was negative 20x. And negative 5 times negative 7 gave me positive 35. And when I combined all my like terms, we get 6x cubed minus 7x squared minus 34x plus 35. All right, guys? Thank y'all so much.